Alright, in this video I'm going to show you how to model a truss like this. It's a 3-member truss, as you see, simply supported. There's a pin support here at point C, a roller at B, and we have a force of 1.92 kilonewton acting at A. So let's see how we could model this. So we open Workbench, and let me delete this. And then we open an application, static structural, double click on here, and then you're gonna have this appear here. Then we go to right click, and then you need to define the geometry. So you go here, open design modeler, ANSYS design modeler. Alright, so here's the environment. And then we're gonna start with the sketching. Alright, so let me see if the recording. Okay, we're gonna start with the sketching, and I want to do it on XY plane. Alright, so draw. Alright, so the unit is meter, so let's do one line goes from here to here. Another line goes one here to here, and then another line goes from one to here. Alright, I'm gonna make sure that dimensions are right. So this length is right now is 0.02 meter. We have to adjust it. In the figure it's 4.5, so that must be 4.5. Another dimension is the vertical dimension from this point to this point. That must be 4 meter. So that must be 4 meter. And now I'm gonna do zoom extend. Okay, let's zoom to fit. Alright, so another last dimension we need to modify is this one that was here. Yeah, alright, so the last dimension is a horizontal dimension from this point to the origin. Yeah, where's the origin? Oh, we can actually do it through by this corner. So that one right now is 0.02, so I need to change that to, let's look at it, it was 3 meter. Okay, so that one must change to 3 meters. Alright, so this is our figure. Alright, so let me see if I can remove this. Alright, so let's zoom fit. Alright, so this is our model. Okay, next thing is, this is a wireframe right now, but we need to, our sketch is done, this is a wireframe, we need to change that to line body. Alright, so do here, you see concept, lines, so you say line from a sketch, I click on the sketch, apply. So now if I say generate, I have a line as a body. Before it was a sketch, but now it's a body. Alright, so a body, line body gonna need cross section too. So as you see, cross section is not picked yet. To generate a cross section, I go here, cross section, and then I'm gonna, since I'm not interested in stresses, I'm just gonna have a rectangular section with 1 centimeter squared of cross section area, you see here. So the height and width, you apply it here, and then when you come here now, since I have cross section area rectangular 1, I'm gonna just go pick that. Now if I say generate, now we have a line body that has cross section assigned to it. The cross section is rectangular 1 and is assigned to the body. Alright, so geometry wise, this is done. Right, so I close this. This model is down. Now we go here to model and open the model. Now next step is going to be meshing and loading and applying boundary conditions or support. Alright. Alright, so we have our model. So let's see if we can have zoom to fit. I want to see. Okay, geometry is imported here. It's a line body. Material is a structural steel. And then we want to mesh it, okay? So to mesh it, I want to just use one mesh, one element per line. So I go here, insert, and then I say, let's see, sizing. I want to click all of them. Let's see, it doesn't let me pick. Yeah, I want to pick this guy, for example. One edge right now is it based on element size or number of divisions? I want to do it, as I said, just one division per element, per line. So I do that. And another one, insert, sizing. I hold control this time so I can pick two lines at the same time. So element size, no, I want to change it to number of divisions to 1. Alright, so all lines are going to be meshed with just one element. By the way, yeah, so right click, generate mesh. Okay, so right now we have the mesh. So let's see. Okay, so next step would be for me to apply boundary conditions. So okay, first let's apply the force. There is a force acting at this node. If you want to pick the node, you can come here, activate vertex picking, so this vertex will be picked, apply. That force is 1.92 kilonewton and is going down in negative y direction. So to define the force, you come here and say component, and in y direction we are going to do negative 1.92 kilonewton. Okay, that's our force. Boundary conditions, supports. So we're not going to do fixed support, we're going to do displacement. So at this point, apply. that point XYZ must be 0, so it's fixed in X direction, in Y direction, and also in Z direction. And then at this point I have another displacement, so insert displacement, okay, so that one I'm gonna let the X be free, Y and Z are fixed. I could use this too, you know, insert, you see simply supported, you know, if you pick this you could have a simply supported here. Alright, so we have it done. We could do another, to keep everything to solution in XY plane, you can do another constraint and apply it to all the lines. You see here, if I click all the lines, right, I can fix everything in Z direction. This way, this will reassure us that everything will stay in XY plane. So right click, insert, and then solve it. Yeah, alright. Okay, so solution is done. Right click. If you want to see deformation, I always look at deformation first to make sure that our model has been done right. So we can, you know, spin it. And we can look at the animation. Yeah, that's what. We need to adjust our view to be XY view. So let's see. Where do we do that? Display. Yeah, viewports. No, I wanna rotate. Oh yeah, views here. I wanna do front view. Okay, front view. Okay, now let's go back to front view again. Let me stop it. Front, back, right, left. Can top view, bottom view is going to be the same. So front view is this. Alright, so this is our deformation. In reality, this is exaggerated. So if you want to see, this is auto scale. So 100 times of the real thing, but the real deformation is this. Yeah, so alright, so if I want to see other things, let's see what else, what other things we can look. So right click, insert. This was deformation, beam result, axial forces, bending moment, you know, shear force, shear moment diagram. We can see those. Right now it looks like we have used the beam in our mesh. So let's see if we can change that to, yeah, you see we have used beam elements. So line body we have used beam elements, but we can change it to link and see how that changes. You know that beam is able to carry bending moment, but trusses are not. They only carry axial loads. Alright, so it looks like you know, this one is not really necessary, this last displacement. So let's see. Alright, so link. Now let's do the solution again. Since yeah, so the difference is gonna be this, you know, if you have beam, the supports here, you know, the way they're connected here, the elements to each other, you could have them like be welded here, right? But for truss or link elements, this point it cannot be welded. It's gonna be just a pivot. So that's the difference. Now let's look at our displacement too, but this is again, right now this is like the true value. Alright, so let's look at, by the way, compare the results. The max displacement deformation, that tells me that we have it. Okay, let's see, let's change this to the deformation to just deformation in y direction. Okay, and then I want to compare the beam solution with truss solution. Okay, so here is our solution in y direction. This point A has moved the most, and it has moved downward. It's negative, so let's see if we can probe it. If I probe it, no, probing feature is not working here. I can do max and min. Minimum point is this, and maximum point is this point. The movement in y-axis. Yeah, so let's animate that. The auto scale. Yeah, so when you look at the front view, the way this deforms, it seems like this is like bending, but it's not really bending, it's just coming down. Alright, so these are deformation in y direction. So right now the model is link, so the minimum, which is you know, actually the minimum, since it's negative, it says this is minimum. So how much it has moved down is we use the meter and Newton as our forces. So that length, this is how much it goes down in meter. That point A moves down 4 millimeter, 44 millimeter downward. So let's see how ANSYS is gonna give us answer if this changes to beam. So if I do change everything to the beam, let's see what happens. So let's see what other options we have here. Nonlinear effects, yes. Yeah, so let's see properties. I want to see what we have here. Alright, so let's do this and see what happens to the solution. So we had 4. Yes, gives us the exact same thing. So seems like with this model, these joints are not welded. So if you just connect them, ANSYS is consider them as like pivot. So so it's not gonna matter here. You model it with truss or with beam. Gives us this the same value. Yeah, but I know that this is gonna be a truss, so I want to make sure that it's truss consistent with the problem statement. Okay, so solve it again. Alright, and let's see what else we can take a look result wise. Beam results, let's see, deformation, contact tool, bolt tool, you see probing. We can look at, let's see what else we got. Beam results, axial forces. Let's see if this can give us axial forces. Yeah, so axial forces. The largest axial force is gonna be this one. This one will be stretched, the red one. This member will be compressed. So like 4,000 is the force there inside that. Alright, so let's see what else we can get from here. Let's say probing is not working. Probing feature. So we just have max and mean. Let's see. So contact tool, probing, coordinate system, beam results, beam tools, user defined results. Yeah, oh I see. This one you can actually take your results and manipulate that, you know, I mean define a function. So we are not interested in this. Alright, so this shows internal forces inside here. So let's see what else we can do. Deformation, fracture tool, probing, coordinate system. Yeah. Alright, so this is, you know, the forces, and I mean deformation and the internal forces are the major things we would like to find, to see in a analysis of a truss. So alright, so this is how you could do this, how you could do model a truss in ANSYS. So you saw that the steps are major steps as we did the sketch, and we had to make a line body and then make sure you assign a cross-section area to it, and then you know, and then apply boundary conditions and find whatever you want, you know, solve it and then find your, you know, find deformation or forces inside. Alright, so alright, I hope this video was useful for you guys.